Hello everyone, welcome to the monthly EVerest Technical Steering Committee. Let's jump to the first slide. We have quickly to show this because there could be competitors here in the room. So let's go. There's a lot of exciting, great news today. We have really packed updates, a lot of performance improvement, functional improvements. If you watch this recording, you can go down in the YouTube agenda and just jump to the next chapters. You don't have to watch through everything if you already know us. For those who don't know what we are or what we're doing, let's dive into EVerest. So what is EVerest? We are a part of the Linux Foundation Energy, which is a big consortium of a lot of open source projects dealing with digitalization of the energy system. And we are basically the interface to EVs, to electric cars, which is not only demand, but it's also basically grid storage. And there's a lot of things you can do in a smart grid with EVs. That's the reason why we're part of this. Let's go to the next one. And so basically what we want to solve in the ecosystem here is that currently the industry is super fragmented. There are a lot of isolated solutions, and the technology is quite inconsistent. Everyone is doing different implementations of, let's say, standards which are not always implemented the same way. And this creates a lot of, let's say, time and money waste, but also really pure customer experiences because things don't work together as they should. Let's go to the next. And EVerest is basically here to solve that. So that's the universal firmware stack, basically, for EV charge point, regardless if it's AC or DC, fast charging, slow charging, bidirectional or not, home, workplace, public. EVerest supports basically everything because it's super modular structured. So you have a lot of building blocks, like you see here on the right. You can reconnect them and wire them up to whatever you need. And there's also a YouTube link, a webinar where we explain that in detail. Next slide. And yeah, as I said, we have a lot of interfaces, like we targeting. A lot of those already happened, like OCPP, ISO interface, MQTT between different entities here, different car interfaces. By the end of the day, we want to fill this entire ecosystem and in every link, all possible protocols. At the moment, we're doing, I think, quite well for public and private charging in Europe and the United States. And Asia is also quite soon on our agenda. Next slide. Yeah, and why are we just implementing all those standards again? Why are we not coming up with something better? Because if we have just a new standard, things would not be solved. It would just complicate the problem. Then there would be even more competing standards. In our opinion, that's not the solution to the problem. We really have to work together on fixing this. Next slide, please. If you want to play with EVerest, Pionix is offering this and other reference designs for charging stations. I think EVerest so far runs on more than 10 different charging stations. This is basically an engineering toolkit where you can play around with charging. It's not meant as a serial product. And by the way, everything is open hardware here, so you can basically build it yourself. Next slide, please. Yeah, there's more hardware available. Oh, we have to add another logo here. ChargeByte offers charge control boards. Phytech Text Instruments are doing this. We today officially can announce that Lumicil is supported by EVerest. And yeah, there's more to come. And if you're interested in this, please contact us. We're happy to support as much as possible. Next slide, please. Yeah, and the ecosystem is really growing. It's not only us and this hardware suppliers, it's also a lot of companies using EVerest already. We can't name all of them, but it's quite a few. We work with a lot of universities, with standardization bodies, and much more in the industry. Next slide. So what's new? So the first news is that EVerest now moved to the early adoption stage. That sounds quite early, but actually it's a second most adult stage in the Linux Foundation Energy open source project lifecycle, and we're one of the most senior projects and also most active projects within Linux Foundation Energy, and we're really happy that we achieved that. We already achieved at the end of the year, but there was some testing framework missing, which is now public, and we will present you in a minute. And yeah, so part of being in early adoption stages, you need to have adoption across industry. It should not be only one company behind this. You should have a steering committee where members are from a lot of institutions are in. You should have a detailed growth plan. Also already showed some traction and growth. and you should follow best practices from the Open Source Security Foundation at the silver level, which is not that easy to achieve. And if you want to know more, just click on those links or contact us. Next slide, please. And here, I think I will hand over to Pete.
Yes, talking about the testing framework. So here it is. We worked on that for quite some weeks, and it is a testing framework for testing EVerest. This is achieved by a Python package that we have created that you can find within the EVerest utils repository. And it contains some utilities that you can use for your test. So right now, it should be really easy for you to write tests for EVerest using PyTest. You can simply require the fixtures we provide within this Python testing package in your test cases, and then those fixtures provide functionality, for example, for starting EVerest, stopping EVerest, starting helper modules in order to integrate them into your test and to test for like certain events that are communicated over MQTT. These utilities that we provide, they are split up within this Python package into, we name them core utils and also OCPP utils. We have written a lot of OCPP test cases in which we use these utilities that we provide there. So there is basically a charge point management system that you can simply require in your test case, and it starts up when you start your test case, and it stops when you stop your test case, and you can use it to send messages from the CSMS to your charge point and check if it like behaves accordingly to the specification of OCPP, for example. We have moved first test cases also to the public repository within EVerest core. We'll have a look at some of them also in a short demo that I will show you in a minute. So you can have a look how these test cases are written and write test cases yourself. I will show you the README quickly, which is inside the EVerest core tests folder. We have described here everything you need for writing your tests and how they work. This is a description of how you install the EVerest testing Python package that you can use within your test cases. And then you can just, if you have a built EVerest core on your system, you can use that. And yeah, there's also a short example of how such a test case could look like, just a few lines. And by just importing EVerest core and the test control module here, there's a lot of like work done in the background that starts it up, and that's you control it in your test cases. And let's have a short look to that. Let me align my screens. So in order to show you what it does and that it actually starts up EVerest and executes charging session, I just entered a command to start PyTest with and specified a test case file and where EVerest is located. So now it's starting up, and you can see here in my Node-RED that there's an actual charging process happening, which is part of the test right now. We are testing for some events. You can see it here in the logs. And yeah, so this is really useful for us. And those integration tests really help us to make EVerest more stable, and also to test like for bugs that are upcoming and also for new features that are upcoming. So let me quickly jump back to the next feature that we have. We already had an energy management, but there was the need to rewrite it to align it with the recent developments that we have made, for example, also for the smart charging with an OCPP. So each EVSE manager now has a broker that buys and sells energy on behalf of the EVSE manager. It is really easy to implement new charging strategies within this new EVSE manager architecture. It supports AC and DC and also mixed environments, which is new. And it also supports bidirectional charging and uses schedules for the import and export of energy. We will definitely enhance the documentation on that because it's not too easy to understand the algorithms behind it. And it was something that we really wanted to get into this release, but we will definitely work on some documentation for that in order also for you to make it possible to extend that and maybe to write new algorithms for it. As I said, it is already prepared for OCPP smart charging. So we have implemented this, the protocol OCPP and all the messages for it. And we are already receiving the profiles and calculating the correct profiles out of it. But it is not, or it was not connected to the energy management in the past. Right now it is not connected, but it's really easy to do that, to do it right now. But it didn't make it into this release. It will probably be in the April release that we connect OCPP to the energy management as well. And also for that, I would like to show you how this looks like by just starting up EVerest with the new energy management config. And this value should reset when we have started everything up. So there's a lot of additional logging here that we have within this configuration. But what I simply want to show you is that we have a setup here where we have 20 amps available, which is the limit of our fuse that we modeled within the configuration. And when we start charging, the first charge point gets the whole 20 amps for charging. And when we connect the second card to the second connector, the energy manager will share the amount of available current between those two connectors to 10 amps, which is just cut the 20 amps in half. And when we stop one car on the first connector, the other one increases again. And this also, of course, works for more than 2 charge points. And it will also consider the limits of OCPP in the future, for example. Let me jump back. This picture shows you what you can actually model with it. So you can model like different fuse setups. It is often the case that you have not only one fuse in front of your one charging stations, but there's a bigger fuse in front of several charging stations, and you can model that. So right here we have this 22 amp fuse, and then 20 ampere fuse, and 16 ampere fuse. And then you can also get external limits from the OCPP backend, which might come from the grid operator or from somewhere else. And the energy manager takes all of this and generates the limits for the EVSE managers that are connected to it.
I think what's interesting to note here is there's no limit on how many layers of fuses you can do. So it's the architecture-wise, it just doesn't matter. You can model whatever there is in reality.
Yes, and it will also be enhanced by like other things that might come into play, like solar charging or like pricing from your energy provider. If the energy cost is low at a certain moment, you might want to charge right now and not later. And this is something that we want to integrate into the energy management as well. Okay, so what's new on the OCPP side is that we, not only on the OCPP side actually, because Plug&Charge was something that needed changes within several repositories. One of them was OCPP, so we have this Plug&Charge feature merged within the libOCPP, EVerest Core, Rise V2G, and Joseph as well. And it is now supported, so there is the white paper that the OCA published for using the data transfer field to exchange messages for Plug&Charge, which is kind of a backport from OCPP 2.0.1. And Hubject itself has some other small requirements that we have also implemented and which is also part of the release, which is basically just some configuration keys that you need for the certificate management that we use. And other than that, we have started already with OCPP 2.0.1. There is a basic setup for it, which you can use and start up. I think we also provided a configuration file to start up OCPP 2.0.1. And we will implement that functional block by functional block. This is the plan for the next weeks and months. For the ISO 15118, there were also changes required for Plug&Charge. So yeah, this is quite some communication that needs to be made for it from the car to the charging system, or actually to the certificate authority, which is Hubject, and provides the certificate, and that builds up the certificate chains. There will be support for Plug&Charge in the simulation. Right now we have written like tests for it, but it's not really included into Node-RED yet and into the seal. And this is something that we will extend, so you can also use it locally on your computer or development machine. And we have started with interfaces for ISO 15118-20, and the first version of AC and AC bidirectional charging is already finished. For the EVso V2G, I would head over to Moritz.
Yes, thank you. I'm presenting the chargebyte contributions to the EVerest project. First, the EVso V2G module. This is a new module for the EVerest core. It is the chargebyte charging stack, which has been in use and deployed with customers for many years now. It's a pure C++ version. And what we're doing is integrating it into the EVerest framework. It is, as others have tested, we haven't used Java ourselves, but it's allegedly more than 50 times faster. So especially the message response times and such are much faster because it's pure C and compiled architectural code and not running through a Java or Python virtual machine anymore. This integration has been going on quite well. I think we reported it last month already that it was working quite well. As of the coming release, the module is part of EVerest core, and the DIN and the ISO-2, both AC and DC paths, are working successfully. So those are integrated well with the EVerest interfaces, and as far as we can tell, ready to use. They've been tested against the seal, they've been tested against real vehicles, and ready to go into proper testing and probably deployment as well. The next steps that need to be done is the Plug&Charge code paths. Sorry, these code paths and the message sets and all the negotiation already exists in the charging stack. It's just not integrated into the EVerest interfaces yet, which are quite different from what chargebyte used previously. So that is ongoing right now. And another step that will happen in parallel is the active use of the new cbExiGen codec, which will replace the existing C-based codec, which everybody is using when they're using the C-based one, the OpenV2G. The ABI and the API are basically stable. Well, the API is, so it's ready to integrate and then test as soon as that is bug-free. So that will smoothen the path to yet another EVerest component being used. So then we can skip on to exactly that cbV2G. We're using, right now we're developing the cbExiGen. This is the codec generator. We have gone public with this today. So the code, as it is in its state as of today, has been made public in this repository and can be reviewed and can be contributed to. I made a note in the initial commit message that there are obviously some restrictions. It isn't perfect yet, and there are some known issues with some messages. That work is still ongoing right now. Some major fixes to the grammar handling to cover some cases which we didn't have before. The encoder part, the decoder was already sort of feature complete apart from the grammar, so able to decode all element types, basic element types. The encoder has now been enhanced to cover all the missing types, except for one, I think, and some fixes for grammars as well. So that's going on quite well. It's basically stuck at mostly the same things the decoder is stuck with. So we're working full time on that. And now, obviously, apart from those grammar fixes to make all encoding and decoding complete and basically errorless, the next steps will be to work with the public. So we'll have to outline the next steps more detailed, so that community can be involved in a better manner, and that we don't do things in parallel and to duplicate the work. Then there's a lot of refactoring and rework that needs to be done on the whole generator, and to make things more practical and to make things more configurable and things like that. And we have a lot of suggestions in the pipeline for making the code more compact by dropping, for example, dropping certain message sets and things like that. And there are also more features which need to be done, possibly for Plug&Charge support as well. So we're looking at all of those, and as I said, we'll probably be putting them on the project boards as well to give an overview of what we have on the roadmap, on the timeline. And that said, we're being functional for the most part for DIN and ISO-2. The -20 has a different infrastructure of the message sets, so we're not quite sure it works perfectly there yet. Or we'll need to do more experiments and obviously work on making the function set complete for the -20. That is basically the next big step and next milestone. So that's the big goal of this codec, to cover -20, which is not publicly, there's no public C-based encoder available for that. So that's that. Thank you.
Right, then I'll have just a few points about the EVerest framework. That is like the framework that we use to facilitate all of this communication between modules. Here, the last couple of weeks, we put a bit of focus on having some more performance enhancements being merged into. Last month, the focus was mostly on some hot paths that we identified in the communication between modules that are now much more efficient, which should result in a quite significant drop of CPU usage of EVerest when it's just idle. And yeah, over the coming months, we'll probably continue working on that and improve the performance for even like lower end or much more lower end devices as well. So next slide, please. And then, yeah, to recap, like Pete and Marco already said earlier, the March 2023 release is out. It's been our largest release yet. And yeah, just to recap some of the highlights, we now have support for generic Modbus power meters, the energy manager that Pete already presented earlier, and the ISO 15118 Plug&Charge support, as well as the new high-level communication module on chargebyte, and we had some Slack bug fixes going there as well. Yeah, that's it about the release.
So yeah, let me continue on what's next. I think OCPP 2.0 and 2.1 is now heavily worked on. The first core infrastructure is there. Now we have to fill that. Hope to get that going in the next weeks and months quite fast. Then C++ exe-based parser and parser generator also for -20. I think this we want to get finished, plus the entire -20 support. That should also be quite soon in this stack. Yeah, then later on, energy management as already mentioned, will be extended for OCPP integration, solar charging, goal setting, price-driven charging. And then there's a lot of other energy-related protocols which we have on our radar. Yeah, so far about the roadmap. Next slide, please. We are on a couple of Testivals, so you can meet there one of us. For example, on the OCA Plugfest in Arnheim, on the Charin Testival, also in Arnheim, on the Comemso Testival in Stuttgart, or on the Plug&Charge Testival in Berlin. And this is just for the next couple of weeks, and the list will be extended. Yeah, and the next technical steering committee will be in about 5 weeks this time, 27th of April, same time again, 5 p.m. Europe time, Central Europe time, or you can just join us every Tuesday, 10 a.m. Central European time. And if you want to see how to get onto those meetings, just subscribe to our mailing list. You will get also access to the calendar there. You can also ask tech questions on the mailing list and also get updates like this, slides, and invites to all upcoming meetings. Yeah, thanks for that. So let's stop the recording and dive into the discussion.